Hello, my name is Young-Han Jang. Today I would like to talk about how EV technology is changing the meaning of safety, not only in terms of vehicle fire risk, but also in terms of human response and interaction. This presentation is organized into four parts. First, why EV safety must be redefined. Second, the new thermal risk in electrified systems. Third, how safety is shifting toward prediction and intervention. And finally, why human response has become an important part of fire safety. First, I will explain why electrification changes the safety framework itself. Electrification changes safety in two directions at the same time. On one side, batteries introduce thermal behaviors that are very different from conventional engines. On the other side, silent vehicle operation and advanced automation change how drivers perceive risk. So EV safety is no longer only a thermal engineering issue, it now requires connecting battery thermodynamics with human cognitive response. This means safety now extends beyond the vehicle itself. On the left side, we see machine vulnerability, especially thermal runaway and fire propagation. On the right side, we see human vulnerability such as sensory conflict, motion sickness, and delayed perception. In EV systems, total safety requires managing both battery risk and driver response together. So far, we have looked at why EV safety includes both machine and human vulnerability. Let us now focus on thermal risk, where EV fire behaves very differently from conventional vehicle fire. One major difference in EV fire is thermal runaway. Unlike internal combustion engine fires, battery fires can generate heat very rapidly, often exceeding 1000 degrees Celsius. More importantly, battery cells release internal oxygen during decomposition. Because of this, the fire becomes self-sustaining and conventional suppression methods such as oxygen blocking are often ineffective. So continuous cooling becomes essential. The risk becomes even more serious in enclosed space such as tunnels or underground parking areas. In these environments, heat and toxic smoke spread faster through what is called the trench effect. Ventilation system can become insufficient because smoke density rises quickly and evacuation routes become difficult to recognize. So infrastructure design also becomes part of EV fire safety. Up to this point, we have focused on how EV fire behave physically. The next question is how we detect risk before failure fully develops. Because thermal failure develops quickly, safety is now moving from passive protection to predictive intervention. As shown this slide, monitoring starts before battery failure becomes visible. AI-based state of health monitoring, long-term battery management system telemetry, and automated fire alerts help detect abnormal conditions earlier. In other words, safety now begins before the actual fire event. However, prediction alone is not enough. If drivers cannot immediately understand the warning, this leads to the final part, human response during critical situations. Even if a system detects danger early, the driver still need to recognize the warning immediately. EVs are very quiet and this can delay recognition of abnormal motion or thermal events. Real-time auditory cues help drivers notice vehicle changes earlier and respond more quickly. So perception support becomes an important safety tool. This is why multimodal warning systems are recommended. Visual alerts alone can be missed. Auditory signals improve reaction speed, and haptic feedback provides physical confirmation. The most effective approach is combining visual, auditory, and haptic signals together, especially during urgent evacuation situations. In conclusion, EV safety must be understood beyond conventional fire models. Battery thermal runaway creates self-sustaining hazards that are fundamentally different from traditional vehicle fires. Safety is increasingly shifting toward prediction through AI and battery management system technologies. At the same time, human response has become an essential part of safety system. Therefore, future EV safety requires both engineering protection and human-centered design. Thank you for your attention.